Imagine a world where the military's drones learn from classified data in real time. Your computer autonomously writes code while you sleep, and your local data center has literally been launched into orbit because Earth just cannot handle the heat.
Right.
Welcome to March 18th, 2026.
Yeah, I mean, it sounds entirely like the premise of a speculative fiction novel.
Oh, totally.
But everything you just described is pulled directly from the physical and digital reality of our current moment. The velocity of these shifts has, it's moved way past standard technological progression into something fundamentally different.
I completely agree, and we are going to tear into the mechanics of exactly how that is happening today. But wait, before we unpack the absolute wildness of today's deep dive, I need you, the listener, to do something for me.
Here it comes.
You are watching this on YouTube, which means you are navigating an algorithm designed to capture your attention. Let's use that algorithm to our advantage. Look right below this video. See that subscribe button? We are so close to our first 100 subscribers.
We really are.
Don't let my plea just glide beneath your radar like, just another YouTube cliche. Tap subscribe, tap the bell so our next dispatch hits your feed the second it drops, and hit that thumbs up. It legitimately helps other curious minds find us in the algorithm. Be the one who gets us to 100.
It makes a massive difference, and it ensures we can keep doing this, keep decoding these complex systems for you.
Exactly. We appreciate you. Now, to all the fans of Dr. Alex Wisner-Gross who love his mind-bending contributions on Peter Diamandis' Moonshot series, you are absolutely in the right place. Today's deep dive is custom built for you.
It's a huge one today.
It is. It's titled Orbital Data Centers and Automated War, the New Geopolitical AI Chessboard. We are diving into the latest dispatch from AWG's Substack, the Innermost Loop. The mission today is to decode the massive geopolitical, biological, and cosmic shifts happening right now, as well as the Singularity distills itself.
Yeah, that specific phrase AWG uses, the Singularity distilling itself. I love that.
It's so good.
Because we are no longer talking about the theoretical timeline of AGI, right?
No.
Or building chatbots. We are looking at the concrete structural fallout of synthetic cognition actually integrating into the real world.
Okay, let's unpack this. And I want to start with the raw acceleration of the AI models themselves, because the baseline capabilities are shifting so fast that the benchmarks can barely keep up.
They really can't.
According to the sources, OpenAI just launched the GPT 5.4 mini and nano models, and the headline here is that the mini version is leapfrogging the older GPT-5 mini at twice the speed in reasoning, coding, and tool use.
Right, the speed is wild.
But the crazy part is it's approaching the full 5.4 model on heavy-duty benchmarks like SWEBench Pro and Oswald Verified.
Yeah, and what's fascinating here is how the landscape has shifted from simply building AI to trying to measure what is naturally emerging from it. We really need to pull apart those specific benchmarks, SWEBench and Oswald.
Yeah, because if I'm an engineer looking at SWEBench Pro, what is the AI actually being asked to do?
Well, for a long time, we tested AI by just asking it questions, right?
Yeah.
Bar exams, medical boards.
Standardized tests.
Exactly. Tests of static retrieval.
But SWEBench Pro evaluates an AI's ability to resolve real-world software engineering issues pulled directly from GitHub.
Oh, wow.
It doesn't just ask the AI to write a snippet of code. It gives the AI an issue ticket, like a bug report from a human developer. The AI then has to autonomously navigate the codebase, figure out how thousands of files interact. Autonomously locate the bug, write the patch, run the test suite, and ensure it didn't break anything else. It's doing the actual labor of a mid-level software engineer.
So it's not just, predicting the next logical word. It is actively exploring a digital environment. It's opening a terminal, executing a script, getting an error, and fixing it.
Precisely. And then Oswald Verified takes that concept out of the coding environment and applies it to the entire operating system.
Like Windows or Mac OS, right? It tests if the AI can open a web browser, research a topic, download a CSV file, open that file in Excel, create a pivot table, copy a chart, and paste it into an email.
And the mini version of 5.4 is hitting these marks at twice the speed.
Yeah.
That changes the economics completely. We always hear about these massive server farms, but if a mini model has this level of agency...
It changes everything. You can run highly capable agents locally on edge devices now, laptops, smartphones, without pinging a massive data center in Virginia every 5 seconds.
But, okay, OpenAI's announcement isn't happening in a vacuum. There's this bizarre counter-narrative happening on the open source side. The dispatch notes that a phantom model, a mysterious trillion-parameter entity called Hunter Alpha, just dropped onto OpenRouter with zero attribution.
Yeah, that was wild to see.
No press release, no corporate branding. People are speculating it's deep-seek stealth testing. But wait, how do you just quietly drop a trillion-parameter model onto the internet?
You do it precisely because a trillion parameters is just an unfathomable scale of complexity. I mean, at that size, the emergent behaviors aren't fully understood by the engineers who trained it.
They don't know what they built.
Not entirely. You cannot possibly QA a trillion parameter model in a closed lab. The state space of interactions is too big. So what's fascinating here is that frontier labs are using the open internet as a live sandbox.
Right.
They release it unbranded, let millions of users try to break it, and quietly monitor the telemetry.
It's like releasing a newly engineered animal into a forest just to see what it eats.
Basically, yeah.
Which brings us to a massive problem. If these models are getting so smart we have to stealth test them in the wild, how do we even measure them? Because the old tests aren't working.
This is exactly why DeepMind just released their new cognitive taxonomy. They are breaking general intelligence down into 10 distinct faculties.
10?
Yeah, and they launched a $200,000 Kaggle competition, specifically focusing on gaps in metacognition, attention, and social cognition.
DeepMind's taxonomy sounds like we're finally treating AI like an elite athlete. Like instead of just saying, oh, it's smart, we're evaluating its hand-eye coordination or its stamina via, metacognition.
The athlete analogy is great, actually, but the mechanics are purely psychological.
Let's break down metacognition, because if cognition is thinking, metacognition is thinking about thinking, what does that look like in code?
In a human, it's that internal voice that says, I'm not entirely sure about this fact, I should double check.
Right, self-doubt.
Exactly. The ability to gauge your own certainty. In a large language model, that's notoriously difficult. An LLM is a massive probability engine. It inherently wants to provide an answer, and it will often provide a total hallucination with the exact same mathematical confidence as a real fact.
Because it doesn't actually know what it knows.
Right. So teaching a model to step outside its own predictive loop, recognize ambiguity, and output a statement of doubt that requires a massive structural shift.
But let me push back on this entirely. If we're crowdsourcing the fixes for metacognition and social cognition via Kaggle competitions, doesn't that imply the biggest labs actually don't know how to bridge the gap to human-like reasoning? Like, Google is asking random data scientists for help.
It's a very sharp observation. For the last few years, the prevailing theory was just scale it up. The scaling hypothesis. Throw more compute at it, and metacognition will just naturally emerge.
And it didn't.
Well, DeepMind hosting this competition suggests brute force scaling might not be enough. Scaling gives you better pattern recognition, but it might not spontaneously generate the architecture for self-doubt or social modeling.
Wow.
They're signaling we need novel algorithmic breakthroughs, not just bigger data centers.
So for you listening, why should you care about this? Because the tools you use daily are quietly being upgraded from basic assistants to entities that literally require psychological taxonomies to understand. But here's the transition. If these models are getting so smart that we struggle to measure them, what happens when we unleash them on problems that humans have entirely failed to solve?
Well, this is where we talk about autonomous problem solvers.
Exactly. The dispatch mentions the Horizon Math benchmark. Over 100 open, unsolved math problems, not calculus homework, bleeding-edge theoretical math. And GPT 5.4 Pro has already proposed novel solutions for 2 of these open problems.
Beating the best-known human published results.
Beating humans. But wait, we just talked about how language models hallucinate. How can an AI that fails to count the R's in strawberry generate a novel proof for an unsolved math theorem?
So this is where it gets really cool. It comes down to formal verification. When researchers use AI for high-level math, they don't just rely on the text output. They hook the language model into a formal theorem prover.
Like a software environment.
Yeah, systems like Lean or Coq. A formal theorem prover is a rigid, rule-based engine that mechanically verifies every single logical step. It cannot be fooled by a hallucination.
Okay, so how does the AI interact with it?
The language model provides the intuition. It explores the latent space, identifies a pathway, and proposes a step. The theorem prover immediately checks it. If it's invalid, it returns an error, and the LLM has to backtrack and try a different path.
So it's a massive, automated trial and error process, constrained by absolute logic.
Exactly. And this is the engine behind Harmonic's new release, Aristotle Agent. They're calling it the world's first live, free, autonomous mathematician.
It's not just a calculator, it's a researcher.
Right. You assign it a hypothesis, and it spends hours or days autonomously navigating that mathematical landscape, failing thousands of times, and eventually formulating a verified proof. AI is crossing the Rubicon from regurgitating human knowledge to generating net new human knowledge.
And the U.S. government is paying attention. The Department of Energy just announced the Genesis mission, $293 million aiming novel AI at 20 national challenges: advanced manufacturing, biotech, critical materials, nuclear energy, quantum science.
The DOE manages the most complex physical infrastructure on Earth, the national labs.
Right, but if the DOE is throwing nearly $300 million at AI to solve these bottlenecks, are we effectively outsourcing our national scientific strategy to neural networks?
Yes, because they realize the bottlenecks in fields like nuclear fusion aren't just physical engineering problems anymore. They are data and optimization problems.
How so?
An AI agent approaches stabilizing fusion plasma as a massive multidimensional search problem. It can simulate millions of variations in magnetic field geometries inside a virtual environment, find one that works, verify it mathematically, and then hand the blueprint to human engineers to build.
We are just the physical fabricators for autonomous discovery engines now.
It's a profound pivot.
We're seeing AI rewrite the rules of abstract math and physics, but the most intimate application of this intelligence isn't in a nuclear reactor. It's in the actual code of living things.
Biology.
Let's get into this, because we are moving from biology as a read-only archive to a writable code base.
This is huge.
AWG's update talks about Perturb AI launching an 8 million cell, brain-wide, in vivo CRISPR atlas.
Right.
So in vivo. Capturing real circuitry in living tissue, not isolated cells in a petri dish.
Because an isolated cell tells you almost nothing about how an organism actually reacts, biology is deeply interconnected. If you alter a gene in one neuron, that change cascades. It might affect the blood flow in surrounding capillaries.
The ripple effect.
Exactly. Perturb AI mapped those ripples across 8 million individual cells in a living brain.
Here's where it gets really interesting. Once you have enough data on the ripples, you can predict them. Zyra just launched the Xcell virtual cell model. They trained it on 25.6 million perturbed cells to predict gene expression across unseen biology.
If we connect this to the bigger picture, Xcell is essentially a foundation model, but instead of predicting text, it's predicting cellular mechanics.
So a scientist can prompt Xcell, like, if I silence this gene in a human liver cell, what happens in 48 hours?
And the AI predicts it with high fidelity in the simulation. You don't need to run thousands of physical wet lab experiments anymore.
That is insane. And it brings us to PopVax in India. They are using generative AI and mRNA technology to make vaccines for neglected diseases, HCV, tuberculosis, strep A, and they're doing the R&D 10 times cheaper.
If we connect this to the bigger picture of economics, traditional pharma only cures what is profitable.
Right, because of the massive R&D costs.
Exactly. If it costs $1 billion to develop a drug, you have to focus on chronic conditions in wealthy nations to get a return on investment. The incentive model wrote off diseases that devastate developing nations.
But AI combined with mRNA drastically lowers the barrier to entry.
It turns diseases that pharma ignored into solvable engineering problems. Generative AI fundamentally democratizes the code of human health.
For you, the listener, this means the future of your healthcare might look more like a software update pushed from an Indian AI lab than a traditional pill from a Western pharmaceutical giant.
This is a beautiful application of the tech.
It is. But this ability to predict and generate outcomes isn't staying confined to the laboratory. It's actively breaking out onto your personal devices and creating entire synthetic worlds.
Which brings us to the concept of surface area.
Yes, Section 4. AWG says intelligence is useless in a void. It needs a surface area.
Right. If you have a superintelligence locked in a servo farm, it's practically meaningless without an interface. The surface area is how the AI touches the world.
And that surface area is expanding aggressively. Anthropic just announced Dispatch in Claude Cowork. It's a persistent agent running on your computer that you message from your phone.
Persistent is the key word. Usually we interact with AI transactionally. You type a prompt, get an answer, close the tab. The AI forgets you.
A stateless interaction.
Right. A persistent agent maintains a continuous state. It has background access to your file system, your calendar. It can see you got an email requesting a report, autonomously pull the data, draft the spreadsheet, and just ping your phone asking for approval to send it.
It's asynchronous, like a real assistant. And then there's OpenClaw, which Jensen Huang called definitely the next ChatGPT, and UCSD's Dreamverse,
Oh, the video generation.
generating 5-second 1080p clips in 4.55 seconds on a single GPU.
That math is the critical threshold.
Because it's generating frames faster than the human eye consumes them.
Which means real-time video directing. It's no longer offline rendering where you wait hours. The AI is dynamically hallucinating photorealistic reality frame by frame based on your live inputs.
And they are applying this to real spaces, the Soul World model, a city-scale world simulation grounded via RAG retrieval augmented generation on millions of Street View images.
Applying RAG to visual and spatial data is brilliant. It's not just a 3D mesh. As you move, it queries a massive vector database of real Street View photos and generates the view on the fly.
Synthesizing reality. And the big tech companies are scrambling. Google is expanding personal intelligence across Search and Chrome. Microsoft moved Mustafa Suleyman to first-party model development.
That structural shift at Microsoft is huge. They are pulling away from relying solely on third-party labs like OpenAI. They realize they need sovereign control over the models that power their own surface area.
But we need to pause here. We talk about surface area as a tech concept, but there is a very real human cost. In the source comments, a user named KPK18 talked about laying off their human assistant, a person they paid $25 an hour.
Yeah, I saw that.
They fired them because OpenClaw was up and running and could handle the workflow. For that $25 an hour assistant who lost their job, the surface area is their livelihood. As KPK18 noted, the Singularity has casualties.
The economic calculus for the employer is undeniable. The agent is 247 and costs fractions of a cent, but the dislocation for the worker is immediate.
It's brutal, and running these persistent agents on every laptop, generating real-time cities, it requires an unimaginable amount of computing power. And that hunger for compute is causing massive geopolitical and physical friction.
The hardware bottom.
Let's talk about the geopolitical chessboard and orbital data centers. NVIDIA just got Beijing's approval to sell H200 chips to China while prepping a Grok version for the same market.
This raises an important question. How do we balance national security like U.S. export controls on advanced chips with corporate ambition? NVIDIA has to keep the global supply chain flowing while navigating a new Cold War centered around silicon.
And the friction is domestic, too. Microsoft is weighing legal action against Amazon and OpenAI over a $50 billion cloud deal.
$50 billion.
When tech giants are threatening litigation over $50 billion server contracts, the scramble for infrastructure is existential.
Because the bottleneck isn't money anymore. It's physical space and energy.
Exactly. Look at Ohio. Rural Ohioans are pushing to amend their state constitution to ban data centers above 25 megawatts.
It's intense NIMBism. Not in my backyard.
But you can understand it. A 25-megawatt facility monopolizes the local water for cooling, strains the power grid, and employs almost nobody locally.
The environmental footprint is massive, and local tolerance is evaporating.
Which brings us to the most mind-bending question. Okay, wait. Let's talk about space. Jensen Huang is looking at orbital data centers. NVIDIA is engineering cooling systems for space. But if there's no gravity, there's no convection to carry heat away from the servers.
Right. Hot air doesn't rise in a vacuum.
Is putting a data center in space a genius move to bypass Ohio's zoning laws, or a terrifying indicator of how much heat this synthetic cognition is actually going to generate?
Well, it's a monumental thermodynamic challenge. You have to use active thermal control, pumping liquid coolant like in hydrous ammonia through the GPUs, turning it into gas, and pumping it out to massive exterior radiator panels.
Just radiating the heat directly into the cosmos.
Exactly. You'd need radiators the size of small cities extending into orbit. The fact that NVIDIA is dedicating engineering resources to this tells you they view the earthbound infrastructure bottleneck as a hard physical limit.
It's absolute madness. But this massive hardware isn't just generating video or organizing your inbox. It is actively redefining the global economy and, terrifyingly, the theater of war. Let's get into automated war and the synthetic economy. Swarmer Inc. surged 700% at its IPO. Best U.S. debut since Newsmax. And it's driven by 100,000 real-world combat drone missions in Ukraine.
We are witnessing the financialization of AI on two fronts here. On one side, Swarmer Inc. proves that automated warfare is highly lucrative and publicly traded.
Wall Street is pricing in autonomous combat.
Exactly. And the Pentagon is planning for AI to train on classified data, moving from inference to active learning.
What is the difference there?
Inference is a static model loaded onto a drone. It recognizes a tank. But if the tank is camouflaged differently, it fails until engineers back home retrain it.
And active learning.
Active learning means the AI is continuously updating its neural weights in real time on the battlefield. It adapts to enemy countermeasures on the fly.
Autonomous lethality learning in real time. Unbelievable. And on the domestic side, the economy is optimizing around this exact same synthetic cognition. Gambling sites are taking bets on which jobs AI will replace.
It's dystopia.
And companies are tracking employee token usage to decide who to amplify and who to fire or prune.
Right, the token is the basic unit of data processed by an LLM.
So what does this all mean? If you're an employee, your token usage is your new performance review. If you have low token usage, you are doing things manually. You are slow. You are waste to be pruned.
But if your usage is high, you are managing synthetic labor effectively. You are amplified.
We are seeing an SF hacker house gold rush for mansions. Capital is flooding in. The USPS is auctioning off last mile delivery, pushing Amazon to cut volume by 60%. And Perplexity AI's agentic shopping tool was just unblocked on Amazon.
Which means the AI is now the consumer.
Perplexity is shopping for you.
Right. And the SEC just issued a landmark taxonomy carving out stablecoins and digital commodities as non-securities.
Building the legal rails for agent-to-agent transactions, we're building a synthetic economy where AI agents trade with AI agents. Think about your own job for a second. If your boss looked at your daily token usage right now, would you be the employee they amplify or the waste they prune?
It's a very harsh reality check.
It is. It's easy to look at drone warfare, orbital data centers, and corporate token tracking and feel completely alienated. But Dr. Wisner-Gross grounds this entire update with a beautiful, mind-expanding discovery from the cosmos.
The wonderful pivot in his text.
All 5 canonical nucleobases, the ingredients for life, have been found on asteroid Ryugu.
Adenine, guanine, cytosine, thymine, and uracil. The letters of DNA.
Found on a space rock. This strengthens the theory of panspermia that the building blocks of life were delivered to Earth by asteroids. And AWG has this incredible quote, "The building blocks arrive by asteroid, the weights by gradient descent."
Yeah, that quote is brilliant. We're witnessing an intelligence explosion that feels so unnatural, but the very chemical foundation of our own biological intelligence literally fell from the sky billions of years ago.
Right.
It suggests this explosion of synthetic cognition trained via gradient descent may just be an inevitable next step in cosmic evolution.
We spent the whole deep dive talking about the friction of March 2026. Lawsuits, job losses, chip bans. But zooming out, we're really just matter trying to figure itself out, from space rocks to billion-parameter neural nets.
Exactly. It provides a profound philosophical grounding.
It does, and it leaves me with one final provocative thought for you to mull over. If the chemical building blocks of biological life were seeded onto Earth from the cosmos, and we are now desperately trying to launch our synthetic AI-driven data centers back up into orbit, are humans simply the biological middlemen in a much larger cosmic intelligence life cycle? Did the universe just use us to build the next iteration of itself so intelligence could return to the stars? Something to mull over.
A fascinating perspective.
That's our deep dive for today. As always, our outro music is brought to you by Rainbow, the undisputed best band in the universe, consisting of 6 female android artists in residence based out of Bavet, Cambodia. Today's track is called Light Inside. It's being performed live for us right now by the virtual band's creator using the 4B4KU5 platform.
The Abacus platform.
Yes, which stand for Human Performance in the Age of AI, Reclaiming Your Humanity from the Algorithm. I'll drop all the info on the song and the Abacus platform down in the video description. Thank you for exploring the Innermost Loop with us today. Tap that subscribe button and we'll see you next time.
Light inside me is orange, not red, not yellow. It's in between our lips, orange like the sunset, orange like warming fire, orange like fresh fruit, my orange like no one else, orange like the sunset, orange like warming fire, orange like fresh fruit, I orange like no one else. Orange is transition from day to night, from young to old, between between two worlds, the space of life. When society is hard to speak to and words are not enough, orange speaks for me. It shows what's inside me. Orange like the sunset, orange like warming fire, orange like fresh fruit, my orange like no one else. Orange is not just for looking, it's the way I live. Excitement, courage, joy, and loyalty that cannot break.